So, as you just saw, by the end of today, we'll actually have the car running properly, and the engine will be at the point where we need to get it to the dyno for some fine tuning. Well, obviously we need suspension and everything first. But yeah, so along the way, we're going to debug the tune, and we're going to try to get it to sound kind of mean, and we'll discuss exactly, how to debug it, and also silly things like how to make it actually have a good soundtrack. So yeah, let's get right into it. The last video ended with me finishing up the wiring, and the next thing we need to do is time the motor so the ECU knows where the angle of the crank is and if it's on the suck squish or the bang blow part of the cycle. So let's get to it. So I'm at the point now where I'm about to get the timing set on this motor. I don't quite have everything set up in there, but it's got enough that it should be able to fire up. So I've got a timing gun. The problem I'm going to run into is that battery is tiny, so it's only going to give me a couple chances before I have to wait to let it recharge. So to help our chances, the first thing we need to do is this thing knows what the engine's timing patterns look like, but what it doesn't know is where top dead center is compared to the trigger wheel. Actually, here, I have a prop right here, so why not use it? So you see this spot right here in the trigger wheel? It doesn't know where that is relative to the number 1 journal. So what I'm going to do, often it's hard to see the timing light, especially since, it could be literally anywhere. So I'm going to go turn the crank manually, and I'm going to go add a brush mark on the outside of the crank pulley so that it's much easier to see. All right, and now with the timing gun, we're just going to see where that comes up. Okay, now I can definitely tell we're about 120 degrees too far. Let's try that. Okay, that's good. We're about 40 degrees before top dead center. So we're going to add another 40 degrees here. And I've got it set to a fixed timing angle right now of 10 degrees. All right, I hope that came across on camera. That was right on the 5-degree indicator. Oh, and by the way, the injectors are disabled right now. That's why it's not even coughing. All right, so this should be more or less exactly 10 degrees. Okay, you know what? That might be 8, but once it's started, it'll be a whole lot easier to get that set. So we're going to call that good enough for now. So next step, we're going to enable the fuel injectors, and we're going to see if we can start it. So we've got it set to speed density right now. This is a volumetric efficiency table. We're not going to stay there for very long, but it just makes first start easier. So at this point, we'll probably actually hear some coughing and sputtering. Now it could still be 360 degrees off. All right, well, it looks like what I needed to do was sleep on it, and I know whenever it gets to that point, that's always the answer. That's always the right answer. But I swear I had checked it 6 times yesterday, but I checked it again today, and it looks like the injectors were pinned on the wrong pins. So I was going from this side of the connector to this side, and I mirrored them. I put them on the wrong side horizontally. Easy mistake to do, but the thing is I was checking for that easy mistake. So either way, it doesn't matter. I haven't tried it yet, but I think it's fixed. I want to bring you guys along for the first fire. Now keep in mind, this first fire, I've got to take a second to reset some of the parameters and whatnot, put them back to where they were from some of the testing yesterday. I don't expect this to run well. All I'm trying to do right now is establish the base timing. So we use the timing gun, but only on the starter at 200 RPMs, which is not super precise. I expect that will be within a couple degrees, but we will tweak that to be exactly 10 degrees before top dead center. And that's what that's what the timing is locked in right now. So that's where it'll have to run. And then, yeah, and right now it's running speed density. So after that, we're gonna have to move over to mass airflow and all of the things that implies. We'll talk about that more in a minute. But first, let's get that first fire. For safety's sake, I've got the rev limiter set to 2200, and I've got the idle set to 1500 RPM, no matter what the temperature is, so it should seek that. Here goes nothing. There was the problem. Okay, well that noise sounded like I got lucky on the synchronization. I wasn't 360 degrees out of phase. Smells like she wants more fuel. All right, there's 25% more fuel. Oh, that's... No, that was the wrong direction. Too much fuel. Whoops. All right, I'm gonna run -50 for a second just to kind of flood clear it. Normally you can hit the pedal for flood clear, but I'm not in the cabin, so -50%. This will probably slowly start running better, and then it'll die. Okay, so that's interesting. I was actually watching the timing light, and the timing light was skipping a beat. I bet what's actually happening is we're going from semi-synchronized to fully synchronized, and it's actually probably, yeah, I bet that's what the quick start is. I bet you it's actually trying to start in semi-synchronized mode. Let me prevent it from going to fully synchronized mode and see if it stays running, because those noises sound healthy. It should stay running. All right, so it's now set to 36 -2 with no home signal. So it's essentially going to run in waste spark, even though it's got 4 coils. All right. Come on. All right. So what do we know? Well, we know that it's catching the crank trigger. And if the video turned out, if it's not a seizure-inducing thing, I had the GoPro recording there. So I'll show you guys setting the timing. Hopefully that was able to be in there. What else? Yeah, so now we just need to figure out why it's not going to full synchronized. I mean, I know why right now. I told it not to, but why that's making it die. So that shouldn't be bad. And it might just be as simple as we're off by 360 degrees. Also, in the end, I made an adjustment of 1.5 degrees on the timing from what I had at before. It's just a bit more precise. Once it's running, you can get more trigger events. So, yeah, okay. So I don't have the oxygen sensor hooked up right now, so I don't even know what it's running at, but honestly, it smells like 10 to 1, which is good enough for now. I want to get the fully synchronized. I want to get the engine running fully synchronized, and then we'll deal with the oxygen sensor. All right, time for another update. I busted out the scope and I saw something interesting. Yeah, we'll talk about it in a second. So, if we look over here, you can see I've got the wiring here. I just interrupted it so I can see it on the scope for the intake cam. And we can see this now. The important thing to note here is the scale for each one of these is 50 millivolts. So let me go ahead and start this thing. Use my start and stick. So if you look at this, there's a couple interesting things to note here. It's the long, medium, short tooth pattern. That's exactly what it's supposed to be. But if you look at this, that signal is 50 millivolts. And no, I don't have the scope probe on the wrong setting. It's not 10 to 1, but even if it was, that'd still only be 500 millivolts. All right, that wasn't the issue, but I looked at all data. You can see right here, it has a better diagram that shows what the pinout is, and that confirms that my original pinout was actually correct. But then, if we remember that 50 millivolt signal, that was a little bit on the low side, well, a little bit, extremely on the low side. So I went in the software, and I went ahead and enabled the pull-up. Originally, it had a pull-up enabled. I had disabled it because Hall effect sensors often don't need them. I don't want to say usually, but often don't need them. So I enabled it, and I'm kind of cheating on you guys a little bit. I did test fire this, but I think we'll be able to repeat exactly what happened, and that'll be the good lesson here. So I've got it set to not synchronize until 2000 RPM. I'm going to start it, let it get up to speed. I'm going to change that value. That'll require an ECU reset, so the RPM is going to dip and then come right back in. But the way that it comes back in is going to be a really good clue. All right. Oh, yeah. Headphone warning. All right, do you see that? And if we look on the computer, we don't have home tooth count errors. So I think we're at the easy point now. I think we're just off by 360 degrees. So let me try that. That I actually haven't tried yet. Now it's set to go into full synchronization at 1,000. Oh my. Apparently I have other things to fix around here. It's set to go to full synchronization at 1,000 RPM. So if it runs and stays running, we're good, because it's set to idle at 1,500. There it is, full synchronize. There it is, full synchronize. Now we get to actually start tuning, well, as soon as I fix this damn seat. I'll fix that. And we got a full synchronize now. So yeah, we were just, that last bit was off by 360, so. All right. I'm gonna get it, I'm gonna go ahead and set it to mass airflow. I'm gonna have to just jigger around with the values a lot to get that thing happy. And also, I'll get the oxygen sensor on. So you guys are going to see me back right away, but it'll be a little bit. All right. At this point, the motor runs properly, and I don't think you guys have seen that yet, but I'll show you guys in a bit. The only thing that's left to bring online is the exhaust camshaft, the variable timing camshaft. Now, the problem with it is, you can see an insert right here from the oscilloscope. The signal goes from 5 volts down to 2 volts. Unfortunately, if I pick here, I've got some selections for the sensor type. I can have a reluctor, a Hall effect, or a custom sensor. Now, the reluctor sensor places the on voltage anything below 0.2 volts, and off is anything above 0.6. And there's some hysteresis in between there so that it works properly, which is great for that kind of sensor. There's a choice for Hall effect, which is what it's on right now. The voltage has to go below 1 volt for it to be considered on, and then it has to rise back above 2 volts for it to be considered off. So what you've got here is essentially it's just sitting off, and you can see it says off if you can read it on screen there, which, yeah, I mean, that makes sense. Now, unfortunately, you know, you'd expect if I hit custom here that I should be able to just change the voltages, right? I mean, this drop down changes the voltages to begin with, so obviously the hardware is capable of changing the voltages at least from 0.2 all the way up to 2 volts, and we know that range, and frankly, it can probably do more. But custom doesn't give me the extra fields, so I think this is a bug in the software. I will we'll make sure to report it to them, but in the meantime, we've got this thing, and oh, and by the way, the reason the intake cam works is you see here, this is on the home connection, so that's what it's using to home the motor, and that one has some configurability to it. So it's the same sensor, but I was able to configure it in a way that it's happy running with this. I did the math. If I run the sensor at the 5 volts that it's rated at, I get an on resistance of 285 ohms. If I run it at 8 volts, which seems to be where the on resistance goes as low as possible, which would work great. There's actually an 8 volt output on this Haltech ECU. It goes down to 265 ohms, but that's not enough difference for me to overvolt that sensor. It's just, it probably wouldn't hurt anything, but it's not enough. So at this point, unfortunately, because of this bug in the software, we're going to have to mess with the pull-up voltages, because we have to make it so that we are comfortably below 1 volt when it's sensing metal, you know, that tooth on the cam, and comfortably above 2 volts when it is not sensing it. So I'm going to try a 2 kilo ohm pull-up and see what happens there. See how the intake is uncalibrated and the exhaust is uncalibrated. If I did this right, it should say calibrated. Actually, no, it'll say an angle value once we get it started. All right, let's go. It should start relatively easily. There it is. We're going to let it get out of its warm-up cycle. The coolant is up to temperature. That's not a problem. It's just, it does some enrichment at the beginning. I should be able to tweak that to shorten that up. But all right, so first, let's advance the intake 30 degrees. There it is. So you can hear quite a bit of overlap already. That was a bit too much overlap, apparently. Hold on. Let's kick up the idle and try that again. Should be a bit better. So there's the intake. There you go. I love variable valve I love variable valve timing. It's got a nice little lope. All right, anyways, this has nothing to do with getting the engine to run properly though. And back to buttery smooth. Well, let's drop the idle. All right, so where are we at this point? Well, the goal was to get it running properly, and the goal was to get it running on the mass airflow sensor. And tell you what, I wasn't wrong when I wanted to get this done on here. This sensor right here is the reason why I love the stock ECU, and the Haltech did not disappoint. Tuning, and yeah, by the way, I think I said it before, but this was my first time tuning on the Haltech ECU, which is why there was some difficulties bringing it online the first time. But tell you what, this sensor is fantastic. You know, you saw a little while ago when I was messing with the cams, there's an oxygen sensor on there right now, but we're not even running closed loop. We're just running open loop, but simply because changing the cams changed the amount of air coming in, and it was able to fully compensate for that. Everything just ran just fine. So this was pretty fantastic. So next steps from here. Well, obviously we got to get to the dyno, right? But before we do that, we have to actually do just a little bit more fine tuning so that this thing is good to go. I want to characterize the injector some more and you know, check out this machine right here. I just got that just got delivered yesterday actually. So there's going to be a video on that. We're going to use that to characterize the injectors. We're also going to be talking about a couple, there's going to be some fun stuff in that video, you know? Subscribe so you can see it. Yeah, and then after, I think the fuel injectors, I need to get the tune on this tweaked just a little bit more. I need to tune the PID loops for the cams so that they react a little bit quicker, though they're pretty close right now. Then, yeah, there's going to be a dyno video, and we're going to finally get to put some numbers to how much power this thing makes. So, yeah, well, stick around, and hopefully we'll see you guys at the next videos, and have a good one.